Hi everybody, welcome to Machines. So we just quickly went over frames, the idea behind frames and how trusses, frames, and machines are kind of brother and sister. They're slightly different, but you kind of treat them all the kind of same way. So we talked about how frames are really kind of similar to how machines work, except that they are multi-force members. In the same way, machines are kind of treated in the same way. So what happens is that if you have a machine and you put in some kind of input force, it is translated into some kind of output force. That's literally it. So for example, if you exert a force P, in this case that's 250 newtons, then you try to figure out what is the vertical component of the force extended on the seal, and then as a little bit of a bonus on there, what is the reaction at point A. So to get started, remember I said I like to use yellow pen for this. I like to draw all the possible forces that I can see on each machine or frame or truss. They're all the same way. If you treat it like that, life becomes a little bit easier for you. Okay, so we know that there's some kind of force being exerted here, and that's based on the question. And then we have FBD, right? Because this is a two-force member, because there's a pin here and there's a pin here. So we have two forces, and that's basically it. So to get started, we're going to say that if we go ahead and draw our free body diagram of a member. Remember in the last example for frames, I said that you find all your reactions. In this case, it's a little bit more difficult because there are a lot of unknowns. So what you want to do is pick a member and get started. All right, so now that we have our free body diagram of the two parts, so we have part 1 in green, and that's A, B, C, and then we have part 2, which is just D and maybe E. Well, not over there. All right, so if you look at E very carefully, you'll see that your press is kind of being held together by some kind of force, okay, which I've highlighted over here. That's some kind of wall on the ends, and I'm representing that with my normal force, or N. All right, so to get started, we pick one of them. So we'll say that starting from point 1, and I like to use black pen to write equations, so pardon me for that. So some moments about A, right? If we some moments about A, we are eliminating AX, AY. We don't worry about part 2 yet, just worrying about part 1. So some moment about A, we have negative 250 times the distance. If you're looking at it, it's going to be 400 cosine angle 15. Okay, so we have 400 cosine 15 degrees, and that same force P going about 250 going about, and multiply by 200 millimeters times cosine of 60 degrees, and that's from right here. So we're looking at the vertical component, the horizontal component of BC. We're also looking at the horizontal distance between A and B, and that's what P is moving about point A. Okay, and then we have FBD, which we have our angle given to us, so FBD times sine 20 degrees multiplied by the vertical distance, which is 200 sine 60 degrees. And we also have FBD multiplied by cosine of 20 degrees, sorry. So you see that we have the sine 20 degree side. So if you're looking at things, it's kind of here, degrees. Okay, cosine and degree equals 20 degrees. So cosine 20 degrees multiplied by 200 millimeters, cosine 60 degrees. Okay, and that's equal to 0. So from this, the only unknown is FBD, and we can easily find out with math that our FBD is equal to 793.64 meters, which tells us that the original direction that we drew our force is correct. Okay, now that you have that, you're going to go straight into part 2. So part 2, right, which we have written right here, very simple. Some forces, let me go ahead and pull that down a little bit. So some forces in the y direction equals 0. We have FBD cosine of 20 degrees. Okay, FBD cosine of 20 degrees, and that gives us the vertical side. Okay. And that has to be equal to basically FD. Okay, or you can say FBD, which is negative, minus FD, and that's equal to 0. And that gives me FD, okay, as 746 newtons. So the force that is being exerted on point D, okay, as a result of the 250 Newton force at C is equal to 746. So with a much smaller input force here, we actually exerting a much bigger force here. And that's because of how the machine works. So if you're pushing down, you'll see that this reaction over here is just going to be adding more. So then we're going to be exerting way higher, which is 746 degrees. Now the question asked us to also find the reaction at A. So we're going to go ahead and do that. So going back to 1. Okay. We have sum of forces in the X. We have AX minus FBD times sine 20 degrees. And that gives me AX equals 271.44. And then sum forces in the Y. We have AY plus FBD cosine 20 degrees minus 250 newtons. And that's equal to 0, which allows me to say that my AY is equal to 495.78 newtons. And those are the two forces. So as a recap, let's go back to this question. Let me go ahead and erase a little bit of the extra stuff going on. We know, as I wrote in yellow earlier, that there are a lot of forces going on over here. Okay, so we have some kind of, based on the question, saying vertical component of the force extended or the seal. So we know that there's some kind of external force here based on the input P. But we have some reactions. At A, there's a pin, so that gives us two forces. And BD is a two-force member, which we've highlighted over here. The trick is to break it up into members. So if you look at A, B, C, that's a single member. So we've written that over here. We have A, B, and C. We have our reactions at A, which I drew on the original drawing. FBD, because BD is a two-force member based on the fact that there's a pin at one point and there's a pin at the other point, and then our external force. Looking at D, where the seal actually is, we know that there's a force that's being exerted downward to push the seal down, and we know that FBD is a two-force member based on what we have raised. So these two are kind of the same. And then we have some kind of reaction. We don't really care about that. That doesn't really help us in this question. But it's always nice to draw that on there. So that's really not needed. Once we have that, it's just a matter of employing everything that we know already. Sum of forces in the X, sum of forces in the Y, and then sum of moment about a point. Frames and machines are not difficult. If you're able to just visualize, figure out where your pins are, what external forces are on there, and then break it up into members. Same thing as we did for trusses, we're doing the same thing for frames and machines. And life will be much, much, much easier for you. I hope this was very helpful. Put in some questions in the comments and let me know if there's something else I need to focus on.